Today, I'm taking my old bike trailer slash shopping cart and recycling it to build a new one. Also, for the first time, I'm going to show you exactly why I use screws to hold my PVC projects together instead of glue. To see me do all of this, stay tuned. If you've seen any of my past PVC build videos, you've noticed I always use screws to hold everything together. The reason is so I can reuse individual pieces in future projects. PVC is sort of cheap and goes together like Legos when building stuff, but if you get a big enough project, it can get pretty expensive, again, similar to Legos. Today, I'm taking my 5-year-old bike trailer, breaking it down to a pile of pieces, then reusing what PVC joints and screws I can to build my new bike trailer. This is going to be a big project, so let's get started. The first thing I'm going to do is dismantle the old bike trailer. Because this was my first ever trailer project, I overbuilt it by quite a bit, so it's going to take some time to tear this trailer down. Here's the entire process at high speed. And these are all the parts that were used to build my previous bike trailer. Let's see how much of this I'll be able to recycle for my new trailer. To get a general idea of what I'll need in terms of PVC and screws, I usually create a rough sketch of my PVC build with different colors representing joints versus pipes. If you'll notice, this design of cart is a lot simpler than my previous one. Once I'm done with the sketch, I'll use it to create a parts list. This is a rough draft of the basic frame, so the parts list may not be accurate, but it will be enough to get the building started. For this build, I'll get a count of the elbow joints, T-joints, PVC pipe, and screws. There are other parts that are small in count, so I won't worry about those at this point. So now that I have this list of parts, I now have to see how much of it can come from the recycled parts. I'll start with the joints because they're easier to pick out from this random pile of parts. I'm done picking out recycled parts that can be used, and this is my revised list of parts. As you can see, being able to recycle parts from old projects really helps. Just these few parts you saw on the floor would have cost an additional $40 at a local hardware store. So though PVC and screws are cheap, it's still worth recycling them in large numbers. One part I didn't write down that is fairly expensive is the threaded shaft I used for a rear axle along with the rear wheels. When researching the wheels on Amazon, they averaged about $15 to $20 each, and I can't remember the price of the axle, but I think it was about $5 at Home Depot. There are other parts I'll need, but I have the basic frame of the bike trailer to which everything else will be attached to, so I'll move ahead and start the building process. I did have to revise the measurements on the drawing to accommodate a specific size storage bin that will sit on the flatbed, as well as a similar sized picnic cooler. In building the flatbed of the trailer, I decided to change the T-joint at the rear of the trailer to a 4-way joint. This will allow me to use the same axle support on the outside and inside joints of the 4-way, providing more overall support for the axle. The inward-facing joint also allows me to have a housing to cover the axle. I'm not going to work on the handle yet because I'm having mixed ideas on possibly constructing this as part of the towing system. I'll get back to this later. For my rear wheels, I'm recycling the wheels off of the old trailer. These wheels, which I got off of an old wagon, are customized by screwing onto the wheel a set of 12-inch bicycle tires. The inner tube for the tire is a foam insert that's sold at Walmart. Probably the most important part of the rear axle setup is finding something the axle can rest on. For the sake of giving it a name for this video, I'm going to call it a bushing. It has to be a snug fit so the axle won't rattle around while the trailer is moving. Also, it's better if the axle can rest on metal to avoid too much wear and tear. Luckily, I was able to recycle my DIY bushing from the old trailer. This is basically a PVC reducer with a PVC pipe inserted into that, then a cut sheet of steel from a can that I rolled to fit into the PVC pipe. For this new trailer, I want to upgrade the metal sleeve the axle rests on by replacing it with something a little thicker that should last longer. Keep in mind, the old one was fine. It lasted 5 years and could have lasted a lot longer based on its current condition. So if you don't have copper tubing, making a sleeve from a steel can is fine. Using standard half-inch copper tube, cut two 1 1/4 inch long pieces. These will become the new sleeves. A half-inch copper tube won't fit in the PVC used for my axle bushing, so I needed to bore the PVC to a slightly larger size. Luckily, I had this strange grinding bit in my collection that was the perfect size for the boring I needed to do. Using a plier, I had to flare out one end of each copper tube so it won't push right through the axle bushing and fall out the other end. Otherwise, this is the revised axle bushing. Basically the same as the old version, except with a personal preference of an upgrade. An issue I discovered related to recycling the axle from my old trailer was that because my new trailer is slightly wider, I also need a wider axle. Rather than waste a perfectly good axle because it's only slightly short, I'm going to use this threaded coupler to draw into the short axle a scrap piece that was cut from the original 4-foot long axle. I'll put everything together and save cutting the axle to length as the very last step. This way, the fit will be perfect and create a nice smooth finish on the end of the nut. Also, the nuts on both ends of the axle should be Loctite in place. I have the rear wheels in. Let's move on to the front. For the front wheel, I'm going to need these parts. To clarify, this is a recycled set of caps that were glued in place at a time when I was not into using screws. The reason I can use these caps is because I only need the top section and not the entire cap. So first, cut off the sides of the cap. Mark the center of the cap for drilling. Drill a 1/4 inch hole in the center of the cap. Because the cap will need to fit inside the joint, use the PVC pipe to get an idea of how much of the cap needs to be trimmed to fit inside the joint. Mark the edge of the pipe onto the cap. Using this mark, I'll carry it all the way around the cap, then recheck it with the pipe. Cut or sand away the edge of the cap up to the line all the way around. You also want to sand down the thickness of the cap. If it's too thick, It will prevent the pipe from being inserted into the joint with a snug fit. Check the size of the trimmed cap by inserting it into a joint to confirm it fits. Cut the wood block to about 1/2 inch larger than the width and length of the caster's mounting plate. Draw lines between opposite corners to find the center. Center punch the intersecting lines and drill a 1/4 inch hole through the wood block. Using 2 hole saws, close in size to the 1 1/4 inch PVC pipe, cut into the wood block about 1/8 of an inch. This creates a recess in the block for the pipe to sit in and adds stability to such a small pipe having to support a caster of a much larger size. Finally, trace the mounting holes from the caster to the block of wood and drill them out for nuts and bolts that will hold the casters in place. Now I can put everything together to make one of the 2 mounting brackets for the front wheel. Do the second one the same way. I had to make a slight revision to the front wheel mounts. Due to a mismatch of the front and rear wheel sizes, the front of the cart now pointed up at an angle. Because swivel wheel mounts need to be level, I needed to angle the build of the wheel mounts so they match the slope of the flatbed of the cart. The change needed to the new wheel mounts was to do all drilling at a slope rather than a right angle. Here's the old and new mounts for comparison. As you can see, even the hole saw cutout is at an angle. At this point, I'll attach the casters to the wood blocks, then attach both front wheel assemblies to the trailer. The flatbed being at an angle was not planned, and it's something I can easily fix by using a couple of T-joints on the rear axle assembly, but I now feel I want to try it like this. In thinking of how items can slide around in a flatbed, this could be helpful in those situations. If I do come across any issues, I'll let you know with an update in the description. If you can think of anything, leave your thoughts in the comments below. One final thing I found with the independent front wheels is that they tend to twist in different directions as the wheel swivels. To avoid a potential problem later, I decided to add this strip of wood linking the 2 wheels, which helps stabilize them. In that case, you could probably use a single plank of wood to mount the front wheels to instead of having each wheel independent. Earlier, I had been contemplating the idea of combining the towing system along with the handle. In the effort to keep things simple for this project, I stuck with my original plan of constructing the handle as a vertical assembly of PVC pipes in a sort of upside down U shape. If I decide to change this in the future, it shouldn't be too hard to do so. The tow bar I'm going to rebuild is recycled from my previous trailer. I really like the design of this tow bar because it allowed for easy removal from the bike without any tools, as demonstrated in the video inset. Here's a close-up of the tow hitch piece that would be connected to the trailer. Here's a close-up of the tow hitch piece that slips over the seat post. Hopefully these close-ups are enough to help you construct the tow hitch, but if you have any questions, leave them in the comments below. The design of this tow bar will be slightly different from my previous trailer due to the height of the front of this trailer, but the adjustments needed should be simple. A 1.5 inch T-joint will go over the 1 1/4 inch PVC pipe to provide a loose enough fit to allow the T to swivel around the pipe. A reducer will be needed to allow the recycled 1 1/4 inch tow bar to fit into this larger T-joint. Combine the pieces shown here, which includes the tow hitch just demonstrated, to form the tow bar. This will attach the trailer to your bicycle. Connect the completed tow bar to the swiveling T-joint on the trailer, securing it with screws. Slide on and secure the seat post half of the tow hitch. The tow hitch must be secured to the seat post. Drill one hole in the seat post large enough to let the tip of a screw rest in it to keep the tow hitch from moving. A large hole drilled in the tow hitch is a viewport to find the hole on the seat post. A smaller hole is for the screw to screw through until the tip of the screw rests within the hole on the seat post. It'll be a shaky fit, but that's fine. And here's how the tow hitch mechanism will work for attaching and detaching. If you don't want to leave the tow bar on the trailer, say for instance when you use it as a shopping cart, you can detach part of the tow bar and leave a short stub on the trailer hanging down and out of the way. For my flatbed, I cut out a sheet to fit just inside the perimeter of the trailer. My old trailer used a 3/4 inch plywood as the bed. This was definitely overkill. This time I'm going to use a 1/4 inch plywood and see how that goes. To keep everything within the flatbed, I pressed fit multiple T-joints onto the rails. Cut off part of the long side of the T-joint. Press the T-joint over points on the rail where you think they'll work best. Now screw the joints onto the rail. Also, if there are times when you need taller posts on the flatbed, insert long PVC pipe into each T-joint. The last cut needed for the flatbed is to mark where each post protrudes through it. Then, use a hole saw to make the cutout. The flatbed can be screwed into the PVC rails, but I'm going to try this without screwing it in place. Screwing the flatbed into the PVC does add some rigidity to the trailer, but I'll go for simplicity first since it seems like it'll be okay. For testing, I could not hook the trailer up to my bicycle, which at the time was being repaired. Instead, I used my Segway Mini Pro to push it around the neighborhood, putting the trailer through similar types of tests I would have done on my bicycle. My first test was to haul 100 pounds of weight to see how the frame and tires held up. My 102-pound son, according to his recent doctor visit, worked well for this test, and so did the trailer. My next test was on bumpy terrain with the same weight. One thing I like about the new trailer is that the front wheels are a lot quieter than the old trailer. The front caster wheels on the old and new trailer were both solid rubber, but the rubber compound is softer on the new trailer, hence the quiet ride. Anyway, the bumpy terrain test also went well. I also tested the trailer for high-speed stability with minimal weight. For this test, I had to use my son's bicycle, which I initially avoided because his seat post is stuck in the frame. Since my Mini Pro is rather limited on speed, I gave in to taking off his seat to get the tow hitch on. I wasn't sure what to expect since I had never even taken my old trailer on a high-speed run. Though not as important a test, since I don't think I'll be traveling with the trailer at a high speed very often, I'm happy to say the test went well. I hope this trailer/shopping cart can be of use to many of you who have a bicycle as a primary means of transportation. My bicycle is not my primary means, but I would like to use it more often since a lot of my driving is because I have loads too large to carry even when the travel distance is short. That's all I have for now, and I'll catch you in the next video.